All right, guys, let's talk about population growth. Another fairly short video. I think you guys will be pretty good at this. It's not overly complicated. But we're going to look at some limiting factors and some growth curves. And this will just kind of support some of the things we've already looked at. So, central questions. What do we want to be able to answer? Well, number one, what is a limiting factor, right? That's probably a good place to start. We want to look at what exactly or what level of information can we pull from a growth curve. We want to look at the logistic growth curve, right, or logarithmic growth curve, and we want to be able to identify the parts of those curves, and we want to be able to identify what carrying capacity is and what that tells you about the environment and the population. So let's start with population. Population is the size of the species that you're studying. So a population could be defined to a specific small area. It could also be the entire range over which a certain species lives. So we get to kind of mess with that. So as an example, how many deer live in Rockbridge County compared to how many deer live in Virginia, compared to how many white-tailed deer live in the East Coast or North America or the northern hemisphere, right? We can change how focused we are on our area for population. A lot of times we like to look at that population compared to the size of the area we're examining, and we calculate population density. And that tells us how many different members of that species live in an area. So if you see something that says like 5 deer per acre, that is an example of population density. If you see, a high number of organisms, that can be used to draw conclusions like, if I have 1,000 deer, well, let's not use deer. Let's say I have 1,000 gophers per acre. It's a lot of gophers in an acre. But that would tell you there must be plenty of food. There's probably not a lot of, predation occurring, right? You could start to draw some conclusions. Now, some of those conclusions need more evidence to back up, but it's a good place to start. So that's what population density is. Now, there are factors that can limit how big a population gets, and we call those limiting factors. So these are concepts or ideas or facts that limit the size and growth of a population. There's two basic breakdowns of those factors. We have density dependent limiting factors, which are going to change with the size of the population. So the greater the density of the population, the more those factors come into play. And then there are things called density independent limiting factors. And these are the same no matter what, right? It doesn't matter how big the population gets. If you can't live in snow, then you can't live in snow, right? If you need a certain amount of water, it doesn't matter if there's one, camel or 1,000,000 camels. If there's only 5 gallons of water, you can only support a certain number of camels, right? So there's density dependent, density independent. Population growth is the measure of how fast the population actually grows. So when we look at the population growth, we look at 4 different things. We look at the birth rate, the death rate, and the 2 forms of immigration, right? Immigration with an I is how many organisms are moving into an area. Immigration with an E is how many are moving out of an area. So if your death rate is higher than your birth rate, let's just look at the first 2. If your death rate is higher than your birth rate, we would expect your population to decline. If your birth rate is higher than your death rate, more kids are being born than people are dying, then we would expect the population curve to go up, right? You would be growing. Same thing with the 2 immigrations, right? If you're immigrating out of an area, well, the population of that area is going down, right? But if you're immigrating to an area, then the population of that area is going up. When we look at all 4, we're basically looking at how many people are moving in compared to how many people are moving out. That's what we're comparing. When we look at a growth curve, we have a logarithmic growth curve or a logistic growth curve. We're looking for 4 main regions, and we try to identify where the population is on that region. The first region is called slow growth. The second one is called exponential growth, where growth becomes very, very rapid. So the slow growth region of a graph looks kind of like that. Exponential growth starts to tail up very rapidly, and then steady state is going to kind of tail off and maybe have a couple little wiggles to it. Carrying capacity is the maximum population that an ecosystem can support in a stable manner. And when we find steady state, we also usually find carrying capacity. Those are two things that are tied together. So let's look at one of these curves. Here we can see we have slow growth, right? There's our slow growth region where there's a relatively few members of the population and they're having kids, right? They're growing, the population is growing, or maybe more organisms are moving into that area than are moving out. Either way, the population is steadily increasing, but not very rapidly. And then here we have region number 2, right? Our exponential growth. Now, there's a lot of kids being born, or there's a large number of organisms moving into an area. Either way, one, the other, or both, the population starts to explode. And at the very top, we find steady state. And as long as nothing crazy happens, that will also be the carrying capacity. Okay? Because what you're looking at here is the maximum number of organisms that this ecosystem, whatever we're looking at, can support, right? There's enough resources to go around for this number of organisms. Now, at the beginning, there is what we call a resource surplus, okay? Because we have enough resources to go around and then some. Over here, we may have resource strain, right? Which can start to occur in this general region when you transition from exponential to steady state. If you go much higher than steady state, you'll have a resource shortage, and that will lead to die-offs, and that's not good, right? It's not good when your population starts to die off. If you zoom in really close to steady state, you'll actually see that it kind of goes up and down and up and down, and it comes in waves, but it averages out to that line. So those are the main factors that affect population growth. I know this is a pretty short video, but again, we're just kind of looking at some vocab and applying it to a few situations. So hopefully now we can identify some limiting factors, things like predation, right? Things like temperature or water supply. We can look at growth curves. We can examine it for resources and what that tells us about our resource or about our shelter or about the overall state of that ecosystem per that population. We can look at the logistic growth curve and identify the 3 parts, and we can identify what carrying capacity tells us. So if you have any questions, let me know. I'd be glad to give you guys a hand.